So, hi James. I was approached by someone on email for I think it was crowd chat or something with crowd conversation for 3 hours, and usually I delete such emails immediately. But what's stuck in mind is some improving unit tests, and I see a lots of problems with unit testing. So I said instead of doing a crowd chat, where I have no idea what it actually is, just do a podcast conversation, and you immediately said yes, and now we are here. But this is an Airhacks FM podcast, so all my guests first have to tell me how they started coding, or what was your first contact with a PC computer or whatever it was. So you remember that?
I don't actually remember my first contact with the computer, but my dad, who was programming on a BBC, remembers very fondly having me on his knee after he'd done about an hour's coding. And I taught him about saving his work as I pressed the break button, as my hands wandered over the keyboard and led to the break button and lost the last hour's coding he had just done. So that really was, as a baby, my first interaction with computers and code.
Oh, okay. And so I assume, and yeah, and this was the experience was so good, so you stick with that?
Yes, so I did. I did end up doing a little bit of programming in BASIC on the BBC when I was in school, and then kind of moving on through A-levels and university into other languages, a bit of C, Java, and for my sins, some Prolog whilst I was at university. And then I actually moved into a career of doing quality assurance rather than being a kind of full-time developer, and I'm choosing my words slightly carefully here because I think I've written quite a lot of code in automated testing and little scripts to help with the system testing that I've done over the years.
Okay, it's the first time I heard BBC. So my first computer was also UK-based. It was ZX Spectrum, and but I never heard about BBC. What was it?
Oh, so I'm trying to think, going back quite some time. So it was essentially it was a microcomputer. It was a box which was mostly the keyboard, and you had a screen on top of it. The language that kind of quite often was used with it was BASIC. And I think back in the very early days, I remember doing what most children try to do with computers and play games, which were all loaded from a cassette tape, which meant you spent more time trying to load the game than you actually did playing it.
Exactly.
And then moving on to the days where sort of floppy disks started to come into being. So yes, it's you're desperately going back to the 80s and the early part of my life here.
Yeah, sure. And why you stick with programming? So why you like that? Because at the very beginning it was not, I would say, not very exciting. So if you compare it with these days, so you had to load a game sometimes half an hour from cassette, and sometimes it even went wrong, so you had to repeat the whole thing again.
Absolutely. And I think the thing that's always inspired me is how computers can make us better. They can allow us to do more and more. And I've kind of through my career typically worked with technology companies and being kind of really got pleasure out of being part of a team that builds a solution that actually helps another person or a company. And I've also worked for a company that's outside of the technology space, a psychometric company, in fact, and had kind of helped their customers being able to deliver sort of better training and do better questionnaires all online rather than having to do paper-based versions. So it's all about really kind of allowing people to be a bit more productive, to use the computers to facilitate what they're trying to achieve. And that's kind of led me to where I am at DiffBlue, in a company that's actually there to help developers be better, be more productive.
That's perfect. But as a kid, I mean, this was not your motivation, right?
Oh, yeah, absolutely. As a kid, it was enjoying playing games, enjoying the challenge of kind of, I guess, building something and, writing a bit of code that actually did something, was it really around the challenge and the sense of success when it worked that got.
But your first line of code, I mean, why you did it? Your dad said, "Okay, write something, and something will happen," or was just, was inspired by a game. This is what really interesting. How everything starts,
I think it would definitely be a gentle nudge from my dad, and I can sort of vaguely picture in my mind a book on basic programming, BBC Basic Programming, that my dad bought when I was still in primary school, and I kind of skipped the early chapters and started looking at the bit at the end, which was a very simple Space Invaders game, because I was kind of keen to give it a try. But the barrier to being able to try it was I had to write some of the code. So I think it's actually an interesting shift that when I was growing up, if you wanted to kind of play a game like Pong or Space Invaders, you could sit there and write it yourself. And I think about my children now. If they want to play a game, they're never going to be able to write a game at the same quality that people will put on an app store for Android or iOS for free. So that kind of that barrier, that challenge that you need to get over in terms of writing a little bit of code and then experiencing the success of it working, seems to be a little bit lost these days.
Yes, except I think what you could do these days is, extend Minecraft with some bigger explosions, which, for instance, right? So you could extend Java code and you could actually extend the game, which would be similar experience to back then, to implement Space Invaders from scratch, right?
Absolutely. I think it's a very different, quite obviously a very different world and very different set of experiences now.
And then you were pleased with the aesthetics, or you just were, you had, the first success to implement the Space Invaders, and then you stick with programming, I assume, right? This is how it happened?
Yes. Well, so I kind of carried on with programming through A-levels and into university. And I did a year out during university where I went and worked for a networking company in their QA team, and I was doing a lot of system testing, stress and performance testing, which was generally quite a lot of time doing scripting. And from there on, most of my programming has been relatively small scripts that have kind of supported something that I'm trying to do at that time, whether it be something I'm trying to do myself in my personal life or something at work. And it's all been about that kind of trying to make my life just that little bit easier and quicker.
Okay. So which programming languages you use? So you started with BASIC and the next one was?
So I kind of went through a few at university, C, Java, and Prolog briefly. When I kind of came out into industry, Perl, which I'm glad I don't have to use anymore.
Writing is fine, but reading is the challenge, right?
Yes, a very good friend of mine described Perl as a write once language.
Yeah.
Yes, and then from there, it's been Java and a little bit of Ruby and a little bit of .NET. So I've tended to dance around a little bit the languages in terms of generally around the skill set of the organization I'm in. But if I go and pick up something myself, if I want to write something myself, I will tend to head towards Java.
Yeah, perfect. So you are right here at all my podcasts. Very good. Yeah, sounds actually good. So it sounds like the whole testing and stress testing story was more like an accident. So you get a job at the network company, and then you started write tests, right?
Yes, it was a complete accident. I got the job there as an intern, and really enjoyed I really enjoyed the testing aspect. One of the things that I struggled with a little bit doing big bits of development is sitting down in front of a computer all day long. I'm much happier spending a bit of time working on the computer than maybe doing some investigation, talking to people, understanding what's going on, trying to get a holistic view of the product and the solution, rather than delving into the absolute minute detail, which is why my career erred in the direction of QA rather than pure development.
Okay, very interesting, because I think I remember a story like 10 or 15 years ago at Microsoft. There were developers and the testers were more like a punishment. This was like, if you did something wrong at the development time, you became a tester or something like this. They changed this, of course, right now, but I remember the old stories from Microsoft. You remember that?
Oh, yes, I've worked for a very large software company, and back in the late 80s, early 90s, their recruitment model was you applied for a job as a developer and then you got streamed. The best of the best wrote new features. The second best people fixed bugs. And the third-rate people did testing.
Okay.
Now, surprise, surprise, if you take the third-rate people out of each graduate intake and put them in a team together, you get a third-rate team. This should not be a surprise to anyone. And when I actually joined that company through an acquisition. And when I joined there were a few people who had been in that company for 20, 25 years, who, when I said I actively chose a career in testing, this completely blew their mind. They didn't understand what this meant. And I think one of the challenges with that old style is there's a very definite skill set that a developer needs, and there's a very definite skill set that a tester needs, and they're different.
Yeah, the tester skill set or mindset is more like a hacker mindset, right?
Yeah, I actually kind of see a hacker or a penetration tester as a very specialist form of testing. And that mindset, that curiosity, that what if, I wonder, hang on, this doesn't quite smell right, I want to go and dig into this, is so key to a tester. Whereas the developer tends to be much more, this is what I'm trying to write, I'm going to go and write it, I'm going to get on with it. Whereas that kind of a bit more, a very different curiosity and that kind of desire to see where the limits of the system are is something that hackers have, penetration testers and most testers have. It just depends a little bit on which skill set they specify in. Yeah,
the developer's expectation is more like that everyone will follow the happy path through the application, and therefore it would always work. This is what
I have actually had conversations with developers before where I've said, you need to fix this, there's a problem here, it can lead to a security vulnerability. And they said, no, the specification says they can't do that. And I'm like, when has a hacker paid attention to the specification? Come on.
Yeah. What's interesting is some of I'm a consultant and I'm working a developer consultant and whatever related to Java into the backends, sometimes JavaScript, but I get sometimes involved in so-called task forces where projects or systems do not work as they should. And this is very similar to testing, because you can try to imagine what actually went wrong, and then we have to often reproduce the error. So we will actually have to hack the system in order that it behave incorrectly, and then in order to fix the error and show that actually it works right now. So it is very similar, I would say, a role to a tester, but for a short amount of time, right?
Yes, I think that's what I've seen with developers doing that is they kind of enjoy the challenge for a bit, and then they're quite happy to get back to their development work after it's done.
Exactly. So now let's talk about testing. So why I was so interesting in the interview with you, because I also performed some code reviews, and I have to say 90% of all systems with tests, they have probably 70, 80, or sometimes even 100% unit test coverage, which in my eyes is completely worthless. So they're all living in a wrong assumptions that everything is tested and there's nice agile projects. And what they just did, they called as much code as possible during the unit test phase, and the asserts are really bad. And in some, you won't even believe, in some projects they invoke new exceptions, new exception, new enum, just to increase the code coverage. So sometimes even enums are tested, which in my eyes is complete defect. So I mean, just increasing the code coverage is like, if you buy a product, let's say TV, you would push all buttons and say now everything is tested without even turning the TV on. So is this Oreo your opinion, or I mean, it's just my wrong, developer mindset?
There's actually an interesting blog post I wrote a little while ago about the 80% code coverage target, which I've been a victim of, I will say, at a couple of companies. And is this a valuable target? What a code coverage target tells you is your developers are writing unit tests. Tells you nothing else. It does not tell you anything about the quality of those tests. It does not tell you whether they are testing something that the user's actually going to do. It just tells you they're writing tests. Now, if we wind the clock back maybe 10, 15 years when unit testing was not as popular as it is today, and developers felt that testing was beneath them, something like an 80% code coverage target was a valuable target, because the goal was make developers write tests. That was the goal. That was the only thing. The real struggle was making the developers do this in the first place. Now, having got over that, I mean, we're starting to see people coming in with projects, as you say, 70, 80, maybe even 100% code coverage. The problem here is not making the developers write tests. The problem is making them write meaningful tests. And this is actually a much harder problem to solve. How do we know that the test cases they're writing are going to add value to the project? And I think the interesting thing, I've mentioned a couple of times now, 80% as a target. Mm-hmm. Is 80% code coverage any better than 79%?
No, absolutely not. And
all of the...
what I do actually, I have to admit, my open source project is interesting. My open source project have very high code coverage, and the reason for that is I'm, the business department and the developer in one person, so it's very easy for me to write unit tests, and I also know what's valuable. And I don't have, lots of meaningless code, because, a small open source projects, I would say 90% of the code is meaningful. So it is really worth to test everything. So business project, a little bit different. So what in my commercial projects, my code coverage is actually fairly low. I would say 30, 40%. But what we are doing, actually, are you aware of Sonar? Of course, right? So, yeah. So in Sonar, what you can do is you can set up a dashboard, and what we do is we combine the code complexity with code coverage. So in my opinion, or what I say is, you are only allowed write unit tests in case the code complexity, the cyclomatic complexity, is higher, let's say, than 2 or 3. It really depends on the project. So you should have at least one if-else in a method to write a unit test. What I don't allow is to write unit tests for enums, exceptions, constructors, and getters and setters, because in the history of Java, it never broke.
And I think you're absolutely right there on the side of code coverage targets. And this is the kind of classic thing that happens is, hey, you need to get your code coverage to 80%. Any developer who's just been given a target of get their code coverage to 80% will write a unit test for the constructor, for the setter, for the getter, because that's easy, it's cheap, it's quick, it's satisfying the goal, but almost in the worst possible way.
Yes, and what I already saw is like, at least in Germany, there was a trend where people wrote libraries, reflection libraries, which invoked, during unit tests, all getters and setters automatically to increase the code coverage.
I haven't come across that one, but it doesn't surprise me.
Yeah, I couldn't believe that, so it was really interesting.
So I think actually when you start looking at the complexity of code, and that is where it starts to get really interesting. And there's a wonderful book and a company based off that book around human factors of code called CodeScene, which look at how complexity changes. Now, what I would see as an interesting view in line with your kind of dashboard is if you've got a piece of code that's got poor unit testing, but the complexity of that code is increasing as new code is merged in, that would start to raise some alarm bells with me, because you're making the code more complex, so it's less easy to review, it's less easy for your developers to understand, and you've got a poor level of testing. If we go back to the getters and setters example, the reason these don't break is because you've typically got, 3 lines? I mean, if you're using IntelliJ, it'll compress it down to 1 for you if it's short enough. You can look at that line and you can see a mistake in it. Very quickly, it'll be really obvious. But as soon as you've got complexity in your code, and I would say if your method scrolls past one view full or one screen full, then you're going to have to try and hold all the information in your head, and that's where the mistakes are going to start to creep in. So I think there's a huge power in saying what's your coverage like over the more complex code. But I think actually more than that, I would love to see people to start measuring coverage against business requirements. What's the desired functionality? How much of the desired functionality have we covered? You mentioned your open source project. It sounds like that's broadly what you're doing because you're the business owner and the developer, and you can do that yourself. The problem with measuring coverage against desired functionality is how do you define 100%?
Yeah. And the next question is not about code coverage, rather than, the quality of the assertions, because you can achieve very high code coverage without any asserts. And in fact, a few years ago, I was in a project where they had, just one assert not null or one assert false. And I asked them, why are you writing so not that many, not meaningful asserts? And the answer was surprising. They told me, because then their build will break. And everyone was happy, statistics were happy, and the project never worked. So I would say what you are demanding is already pretty high. I would say let's start with introducing more meaningful asserts, like, basic assert that, and at least, I even, try to, I think a good metric would be just to see the ratio between assert null and not null and assert true and false against something more meaningful asserts, right?
Absolutely. And I think there are some rules in Sonar that when they do the scan of the test cases, they can ask for specific conditions on the asserts. I think one that I saw recently was around having messages. So every assert must have a message of what it means when that assert fails, which means you've got to have thought about, what am I actually testing here, and what's the problem when it goes wrong? So, it's not insisting people write good asserts, but it's certainly making them think about what they're doing. And I think a lot of the moves now should be around making people think about, what are they testing, not just the act of writing, I'm covering this piece of code. Why are you covering it? What's the benefit to testing that piece of code? What's the problem it can cause when it goes wrong?
This is actually very similar to the same problem with Javadoc. So if you have, to write proper Javadoc, is actually exactly the same problem as writing proper unit tests, right? Because if you write Javadoc comments, they have to be expressive, and you will have to write why you wrote this, or you have to explain why you wrote the code and what was the intention behind. And unit test for me is just executable Javadoc. So if you do it right, it should express, why the system is there, and it documents how the system can be used.
Absolutely. And actually, I talk a lot with some of our customers here at DiffBlue about introducing understanding of the code through unit tests. Java developers understand what a unit test does. They know how it works. So actually, when we create unit tests, we're saying this is the behavior we expect from the code. It's kind of like a contract for the code. So when another developer comes in to change it, they know what was in the mind of the developer to start with. So as you say, it's exactly like a good Java doc, just executable.
Perfect. And so I spend my time mostly in Java project, Java EE backend projects. And so as you probably know, most of the projects are better database browsers, not like we always write highly sophisticated algorithms. We just have CRUD operations, create, read, update, delete, talk to the database, some validations. I would say this is most of enterprise project what they are doing, or integration with backend systems. And therefore, we don't have too much complexity. So I let write unit tests just for the complex code, as we already said. And then for me, unit tests are, I would say, they are just used to increase productivity, because the developer can test everything locally. She or he doesn't have to push the code, to deployment environment or to the cloud to start up the services and runtimes. So you can speed up your productivity. And the next step would be integration tests, where we go a little bit. We are able to start, for instance, the entity manager, which is behind, which is the API for Hibernate, or JPA, so you can test the whole persistence locally without starting the server. And this is also optional. And for me, what is absolutely not optional in microservice world are the so-called system tests. And or there are different names for that. I just always pick the names from Wikipedia. Otherwise, I would spend the first 3 days in projects and defining the names. This is like the Parkinson law of triviality. So whatever is trivial, you spend endless time discussing that. So like system tests. What I mean by system tests, you have a module, and this module accesses my microservice via REST, and tests like a black box from outside. And for me, this is the most important test, because it actually tests in production-like environment whether the system is working. And everything else is only needed, to have more, I would say, complete view, or will be able to test the untestable things which are not available from outside. Let's say we are an e-commerce shop, and I could write a unit test for the tax computations, but the tax computations or calculations are not exposed via REST services, because we are selling stuff and we are not exposing, the taxes. So it's also your point of view that the most important tests are actually, the more holistic tests, because this is the absolute truth. And anything else is like, being more productive, and it's like a tools to doing the job. And the ultimate test is the black box test.
I completely agree that the black box testing is the most important testing. It's the one that closest replicates what the user's actually going to do with the system. And therefore, you just can't skimp on this, despite many companies' attempts to do so.
Yeah.
You really can't. And the more time you spend there and the more time you spend with people who are great at doing things like exploratory testing, the better the product will be. But you've mentioned a couple of the challenges that can't be solved there. And one of the things that I find very interesting is the kind of error scenarios. And unit testing particularly is very good at checking the code that you put in to cover error scenarios. I mean, if you've got a database system and the database falls over in a way that you didn't quite expect, and how's your system going to behave? Do you know exactly what's going to happen with the error handling? I mean, Java's relatively good at times at just throwing up runtime exceptions back to the user, for example. How much information gets given away at this point? Now we're straying into a little bit of security testing, but when you start being able to have confidence in your abnormal or your error scenarios through your unit testing, you have better confidence of how the system's going to behave when things start to go wrong. The other point, which plays absolutely into the hands of productivity, is a little bit of traceability through the system. And I will hold my hand up as a kind of career QA engineer of raising a bug where the developers have gone, that can't happen. And I've said, well, come and look, I can show you it happening. And then they've got to work out, where is that bug in the system? Now, the more integration testing, the more unit testing you've got, the easier it is to see where the bug actually exists. Because when you start doing this black box testing, of course, you're describing the bug in user terms, not pinpointing the bit of code that's gone wrong. So by having a good suite of integration and unit tests, it's going to make that debugging a lot quicker. And we all know that the later in the cycle you find the bug, the more expensive it is to fix. But we can start trying to reduce that cost a little bit by having those tools and those tests that allow us to diagnose the problem quicker and easier and cheaper.
Absolutely. But what I see in projects right now is the system tests are absolutely ignored, and everyone is happy with unit tests and code coverage because this is the metrics which every manager would like to see. And what I already experimented with in several projects, and it worked really well, what we did is we used the system test, which is an completely separate Maven module with in most projects just with HTTP client, which in my world is JAX-RS 2 client, which calls via network the actual microservice. And first, I don't have to use curl, to test my system. I can reuse my system test to do that. So this is also somehow, captured way how the system is used. But now comes the hack or the improvement. What we did is we started the runtime, the application server, with Jacoco, which is the code coverage agent. And now the question is, if you have a black box test, and you run all the black box tests, actually, the majority of the code should be covered, because what is left over, as you said, there are the error scenarios. And now the question is, can we really test them via the system test? Would be the best. If not, we could use unit tests for them. And why I used it for me, because I can detect unused code, because I forget some code parts, and if everything is covered and some code piece is left over, I see, I forgot the code, and I can immediately delete it. So and this approach is just not that popular because it does not get encountered into the statistics machinery by most QA departments.
I think there's actually some other reasons why it's not so popular as well. First of all, you're right, it's not counted as the stat in the stats, but also it requires some it requires what I would call some development resource or knowledge. And it's very similar to something I've done before in a previous role, where I ran some testing I did for a new feature on a code coverage enabled build. Now, it was C++ code, so not Jacoco, but gcov instead. But in that case, what I needed was the build engineer to produce a version of the product with a code coverage enabled build inside it. And the challenge here is it just doesn't seem to have gained popularity. For me, it was very interesting to see, having run through the test suite that I built based on the specification, the black box test suite I've created, how much of the code have I hit? And of that code that I haven't hit, what's it actually there to do? If I'm confident I've tested everything that the product manager wanted that code to do, what's the rest of it there for? And how can the user execute it? So I'm actually all in favor of this idea of measuring code coverage across all of the testing that you can do. The problem is that it's just not as easy. It's a lot harder to do. And I think unless sort of management demand it, then where's the incentive for the teams to do it?
The cool story is in all product teams where we're building products, we are doing just that because the added value is clear. In more project where you have consultants from different companies, they are absolutely not interested in such a thing because they only would like, to deliver these stats and everyone is happy. So if you are really interested in your project, you would do something like this. But if you're just developing something because you're a contractor, who cares?
Yeah, exactly.
And the last thing, because stress tests. So the stress tests are, in my world, driven by JUnit. So they are, as you already said, additional documentation. But the interesting part in the system test is they can be also used as additional. Even this is ready to use stub for a different microservice. So this is truly, I would say, test driven because you can just take the system test, delete all the asserts, and we have a microservice client which can be shared with another team. So this is the first one, less interesting in today's conversation. But the second thing is, you already mentioned stress tests. What we do then, we pick the system test and then just reuse them completely and write system tests, stress tests, or torture test, actually. Not reasonable load tests. I would really like to break the system, see whether my application server, survive, and whether the metrics which are exposed directly from the application server are actually correct. So do we have, commits, rollbacks? Does everything looks right? Does the heap looks right? Do we have memory leaks and something like this? And I use JMH, for instance, Java Micro Benchmark Harness, to just generate massive load on the servers. So the system test, interestingly, is actually reused several times. Once is to be able, as developer, to invoke the system at all without Postman or curl. Then is used, for the actual black box tests. Then as a documentation for other teams, and then as a stress test input. So, what's your take on stress tests and torture tests? For me, they are crucially important for all distributed systems. They are also ignored, except we get task force. Then everyone knows. Okay, now we have to do some performance and stress testing. And funny story, one company I was hired once a year after release because they always had stability and robustness troubles, and then the management asked me lessons learned, and I think in the third year I sent them the old emails from years before, just do some stress testing, and they did them for six weeks, and they say they were always successful, and they stopped doing them, and then everything broke again. So this was also one of my best best contracts, but also most funniest one. So what's your take on stress tests?
I think stress tests are absolutely valuable testing for so many different organizations and projects. And I'm reminded of a retailer in the UK who big online shop, big e-commerce solution. And about 4 years ago, the last week before Christmas, their online shop went down. Now, this is pretty disastrous for a retailer in the run-up to Christmas. Big profits to be had, and their online shop goes down. The next year, same thing happened again. And I happen to know someone who worked there, and they said the IT team said that we shouldn't worry about it because it wasn't as bad as the previous year.
Oh, there was improvement.
There was improvement apparently somewhere. I can promise you, not from a user's perspective, because I was trying to order my wife's Christmas present at the time and was very frustrated.
But the code coverage was higher, right?
I'm sure it was. But the point here is, you can build a system, you can run a system in that environment for 11 and a half months of the year. And if you have not done any stress testing, I can promise you one thing: your customers will stress test it for you.
Yeah.
And that is it. Is just, torture testing is a great way of phrasing it. My personal view in that environment would be take your max load that you've recorded over the last year or two and double it, treble it, find out what happens when you get that peak load. Concert ticket sellers, online retailers, so many of them have been hit by bugs because they've not expected a load that they're going to get from their customers, and the systems are just fallen over. And having been in a company running an e-commerce solution, what I really want to know, I accept the fact that bugs happen and that the system's going to fall over. When I've got the chief commercial officer on my back because his e-commerce site's not live, I want to be sure I know exactly what's gone wrong and how quickly I can put it back together for him, because that's the only way he's going to get off my back.
Absolutely. And by the way, I was not this was not the contract from your UK retailer. This was another company, but very similar. But except the code coverage was there was no improvement at all in my world. Okay, so by the way, you are the first tester who agrees with me with all the definitions. Usually, the stress test is no one is interested in companies. So stress test is even more rare than system tests, and for unknown reasons. Which is actually, if you think about this, is absolutely crazy. It's just like delivering a bicycle without testing the brakes or something. It's just like this is insane. But this is how the software world works today. Now. You are working for DivBlue, and I understand DivBlue is like a spin-off of a university project, and it uses AI for generating tests. Now the question is, we defined, in my world, what unit tests, integration tests, system tests, and torture tests, how they are defined, what they are doing. Can DivBlue, whatever it is, help us with something? And what is DivBlue? What you did, and just tell the story, because I tried to find it out through the website, and I'm not. I think I understand what happens behind the scenes, but just to our listeners, can you just briefly say what DivBlue is doing and how it started?
Absolutely. So DivBlue started about 3 years ago, and it is a spin out from Oxford University, and our CEO, Daniel Croning, and a number of his colleagues have been working on a tool called CBMC, which is doing reasoning about code. And there are a lot of companies out there who have used CBMC to find out how their code behaves. So if you think about sort of back earlier on, some embedded systems companies, so some of the car manufacturers and other companies like that get really interested in what they can understand about these systems they're embedding into the cars. Probably most prominently, AWS have a contract with us where they are looking at finding problems within their online platform. And if you look on our website, there's some information on the work we're doing with them. But DiffBlue Cover, which does unit test generation for Java, is our first commercial product rather than consultancy that we're doing. And DiffBlue Cover is very simply, give us some Java code and we'll produce unit tests for you. Now, what it's doing is it's interpreting the Java bytecode and it is generating test cases for each of the paths through the code. And what this means is it's going to produce you a unit test case with an example input and an expected output for a particular path in the code. And what we're focusing on here is improving your productivity. What we want developers to do is spend time thinking about what is being tested, not spend time writing a unit test. So I'm going to hold my hands up here and say, DiffBlue Cover does not understand the business case. It will not produce a really exciting, well-reasoned, business-focused unit test. It will produce a test case that tests a path through the code. And what we see people doing quite a lot with this is saying, okay, that unit test, I don't know, maybe testing this particular path through a login function. I'm going to change the input and just make it something that's much more meaningful to our business. But that means that in a unit test that's maybe 15 lines long, they've edited 2 to generate unit tests they would have otherwise written by hand. So what we're trying to do here is make the act of producing unit tests quicker, easier, and therefore allowing the developer to spend more time thinking about what is being tested and making sure that those inputs are right, and then spending more time developing new features. So we really are playing to that productivity game.
Oh, very good. So what it means to me is, so if we have meaningless, let's say, data containers like DTOs, the AI would just not generate too much because, I mean, getters and setters, there is nothing to generate except checking for null. So you could skip that. But if I would get, some code with if-else statement, DiffBlue will try to generate something which covers all the branches. And so then I don't have to write this scaffolding code. I will just focus on the higher value asserts, right?
Absolutely. So we will try and produce as much coverage as we can across that code, because we're not going to try and tell people which tests are valuable to them and which aren't. And then it's up to you to take the test that you want and focus on the asserts, focus on the inputs. So if in the case there, if you've got something with a simple if else, then we're going to create 2 test cases, one for each side of that if else branch. So we're going to give you 2 test cases, and you can focus in on, are they the most meaningful or not? Now, one of the applications that we're seeing come up time and time again is there's a lot of old legacy Java code out there where there's very little test coverage and people are scared to go and change the code. And actually, what we offer with DiffBlue Cover is this opportunity to generate a lot of tests very quickly compared to humans doing it. Now, in this case, I would actually go the other way and say, don't worry too much about the inputs and the asserts. I would say, if you've got a sizable Java project with no coverage and we've produced a few thousand tests, just use them. Only worry about them when they fail. And then what you can do is get an instant regression suite very quickly, and then you can start worrying about the quality of those test cases as you're working in the area. But at the same time, having the confidence that other parts of the code aren't being broken as you make your changes. Then as you move to a more kind of iterative development, and we're giving you maybe half a dozen test cases for the class you've just written, at that point, you really want to focus on those inputs, focus on those asserts, and make sure these are the best test cases there can be. So we've got a tool here that we believe is flexible. It's going to allow you to use it in the environment you want to use it in, but improve the agility of your development team.
I think the killer use case could be even, migration of legacy applications to a newer platform or standard. I remember a few years ago, I was asked, to migrate an old J2E application to Java 6, 7, I think it was 7. And the project was not very big, but it was very bloated. So lots of meaningless modules and layers without any functionality just because they had the layers. And I think I proposed something like 8 weeks, which was a lot. And they asked me why. I say, okay, I will migrate. Probably there's nothing to do for migration because it will probably just run on the newer server. But no one knows actually whether it will run. So I will have to write tests first for the application and run it on the old system and then repeat the tests on the new system, because otherwise I can just tell you it starts on the new system and no one actually knows whether it works. So what you could with that is to generate tests and make it run on the old legacy platform. And then after migration, rerun the tests and it should just work as before, right?
Absolutely. And the words in what you've said there that always scare me when developers talk about projects is should. Everyone loves a developer who says it should just work. And you're absolutely right. What we're offering is more confidence, the ability for the developer to say it will work because the tests that ran against the old system run and behave the same way against the new system. And that 8 weeks of writing tests, we can compress down to a much shorter period of time. We'll be measuring that in days, not weeks.
Yeah. And how it actually works, is it like, right-click in the IDE and generate a test? You have this commercial offering. So if I buy something, what I'm buying, do I buy a IDE plugin or how this works?
So what we're selling today, we're obviously selling software. And we're selling a system that you could run it's a series of Docker images. You can run it in a cloud provider, or you can run it on your own data center, or even on a single node. But once you've got that up and running, with most systems these days, there's a web UI, which is great for that kind of migration project where you can throw the code at it and it can work whilst you carry on with something else. But for the more iterative development, the newer projects, we've got a couple of plugins today, one with GitLab and one a kind of generic CI plugin. And these will allow you to get test cases as you develop the code and push it to your repository. And in the next few weeks, we'll be releasing an Eclipse plugin, which is almost exactly as you've described. Right-click on a class and say generate tests. So that's the commercial offering that we've got. If you're interested in trying out the technology, we have it's called our Playground, which is basically a demo version of the tool, and it's on playground.diffblue.com. And this allows you to put a single class, about 200 lines in. So it's not going to do your whole project, but it will give you an idea of what we're doing. And you can ask it to write tests, and it will show you on the right-hand side the test cases that it's written for the code that you've entered. So it's a great opportunity for people to have a little trial of our tool without having to go through all the effort of signing up for a trial agreement.
How smart, or is the generator extensible? So what I'm thinking about is in my Java EE world, lots of dependencies are injected with @inject. So the code looks like @inject, let's say data source. So what I usually will have to do in unit test is to mock it out. So what I use Mockito. So the code would look like data source ds equals mock data source and then record the expected behavior. Could I just plug in and say, hey, generator, if you see at inject, do something like this?
So currently, when it encounters something like a data source that's outside the system, is it will generate the mock that's needed. So it uses Mockito and PowerMock. And what it will do is it will say, to exercise this path through the code, I need this returned from the data source. So it will generate the mock that will return that.
Exactly. This is what I'm doing before in my unit tests. Mm-hmm.
So rather than you writing the mock, DiffBlueCover will write it for you.
Okay. And would it be also possible, to have a set, let's say, of annotations, or how to tell your CI where the test has to be generated or not generated? I would assume you can have a threshold of complexity, so you can say everything which is complexity higher than 3 generate the unit test, otherwise don't generate. Or will you generate the unit test for everything, or how does this work?
So today what we're doing is we're generating tests for anything that's not covered by the existing tests.
Okay.
That's because a lot of the people we're talking to at the moment have those code coverage targets that we've spent quite some time saying are not great. But what we do have is an interface into the system where you can tell it what to test what to generate tests for, or what not to generate tests for. So our CI plugin is actually, or will be, it's not quite there yet, but it will be on the Maven Central repo. So you can extend that and say, okay, I actually want to have a complexity measurement of the code, and I want to tell it to only generate tests for things that have a greater complexity. It's a bit more work from the customer side at the moment, but once we've released that CI plugin to Maven Central repo, people are free to extend it and add in bits that they want, and we're really interested to see how people choose to build this into their processes.
Okay. And how AI is involved? I just was on your website, and there is AI multiple times. Is this already AI somewhere there in your product? Or for me, it sounds like a smart generator without any deep learning, right?
So where AI is involved is where it's doing deductive reasoning of how the code is behaving. And I will point you to our blog. There is a blog post titled "What is the AI in AI for Code?" that our CEO Daniel wrote, where he explains a lot better than I can exactly where the AI is. And for anyone who wants to go deeper than that, we have some of Daniel and the other founders' research papers on our website, which definitely go deeper than I can.
Okay. And what's also I'm curious about, if I get the Docker images from you, can they work offline, or do you need a cloud connection, for the analysis? So the all AI analysis happens on premise?
Everything is contained within those Docker images that you need. The only thing on top of that is some code to analyze. So we work with a number of financial institutions, and absolutely key to them is everything stays on premise. It never comes out of their network. So we've kind of built our product in the way that it will not dial home to us at all. It is absolutely completely contained within the environment that you set up.
And do you have any open source strategy, or you don't following the open source at all? Do you have any ideas on that?
So we actually do a lot of testing against open source repositories because that's a great source of some code for us to do some real user testing against. And where we cases against open source projects, we offer them as PRs to those open source projects. And on our website, there's a page. So it's diffblue.com/open source, which gives people the opportunity to look at some of the PRs we've had accepted by companies like Amazon, SAP, Hotel.com. And also there is an opportunity for you to submit your own Git repo. So if you've got your own open source repo that you would like to see some test cases for, if you fill in the form there, we'll get one of our team to run it through the tool and send you a PR with some test cases.
Okay, that sounds great. So if you have an open source project, you can get your code generated, your unit test generated for you with Diffblue. Perfect. So any final thoughts or links, so where the listeners can find more about you and Diffblue and your products?
Okay, so absolutely. Our website is a great place to start, www.diffblue.com. To hear more of me talking about my thoughts and views about software development and testing, our blogs, diffblue.com/blogs, is a great place to see some more of my thoughts. But the final two pieces are please go and try out Playground, playground.diffblue.com. And finally, you mentioned the crowd chat. On the 15th of May at 3:30, we're hosting a crowd chat on Twitter, and there'll be more information appearing on our blog and our own Twitter feed. So keep looking out for those.
And you are on Twitter as well, right? It's at Diffblue, I think.
Is it Diffblue HQ?
Yeah. And your name is James Wilson. Yeah, also Twitter?
I am. It's JG Wilson 42.
42. Oh, of course, 42. So now we have the answer to all questions, right? So
Absolutely.
Thank you for the interview. And if you have any upcoming products, let's talk again.
Will do. It'd be great to talk again when our next products are coming out.
Bye.